Hey, today I'm going to talk about 10.1, which is an introduction to what we call hypothesis testing. Okay, so let's start off with an example. Let's say that someone said, oh, hey, the average number of energy drinks that a person has in a day in the US is like 1.2. Okay, so this is a statement that is put out and it's considered to be the truth as everyone knows it. So how would you write that as a hypothesis test? Basically, this is what we would call the null hypothesis, which is the statement that is already out there. So the average number of Red Bull or of energy drinks per person in the US per day is, let's say, 1.2 or something like that. Okay. So as a researcher, you're inclined to challenge this. And when we challenge something, we call that an alternative hypothesis. So you're going to say, I don't really think that's true. I challenge that. And so you're going to come up with this alternative hypothesis. You don't believe that the average number of energy drinks is 1.2. Now, let's say that in your experience, you believe it's greater than that. So you're going to say, well, my alternative is that the average number of these drinks is greater than 1.2. You could also say that you think it's less than that. So you might say, no, my alternative is that the average number is less than 1.2. Or you could not necessarily commit yourself to being greater than or less than, but just challenge it by saying, no, I think that the average number is not 1.2. So it could be greater, it could be less, but I just feel it is not 1.2. So these are the three different types of alternative hypotheses that you may make. Remember, the alternative is your challenge to the null, which is basically the status quo. The null is what's believed to be true, and the alternative is your challenge to that. Okay? So something to keep in mind is that we have names for this alternative versus this versus this. Okay, so this one, think of, let's say I had a picture on a little normal curve or something like that, and here was the 1.2, the status quo, and you're saying, no, I think it's above that. Or in this example, you would say, no, I think it's below that. Or in this example, you would say, well, I don't know if it's above it or below it. It could be either, okay? So it could be above it here or below it there. And I know this feels a little bit weird, but anyways, if you think of this picture, this is what we would call a right-tailed. This is a left-tailed because it's shaded on the left. And this is a two-tailed. Okay, so there are going to be some questions where they ask you whether or not the alternative was a right-tailed, a left-tailed, or two-tailed. So think of it as where that shading would be. Now, if I think it's greater than 1.2, it's going to be right-tailed. Less than 1.2 is left-tailed. Not equal to 1.2 means it could be above or below. So that's a two-tailed. Okay, so those are our hypotheses. Those are our null and our alternative hypotheses. So something that I want to point out when you're creating your null and your alternative is that this is always going to be a population. So you have to recall what your population symbols could be. So this one means mean. You could have also had a P for proportion. You also could have had a sigma for standard deviation. Okay, so you've got to decide based off the narrative, are they talking about a mean, a proportion, or standard deviation? Once you determine that, it's going to be the same in both cases. You can't have a null being like the status quo is that the average number of energy drinks is 1.2, but then your challenge talks about a proportion. No, your challenge is going to talk about the same parameter that they use. So these two will always be the same within a specific study. Okay? These will always be the same as well. If they're talking about the average is 1.2, then your alternative has to refer to the same number of 1.2. You either believe it's bigger than that, smaller than that, or different from that, but you're going to use the same number. Also, the null hypothesis always uses the equal sign. You'll never see that in the alternative. You'll always see that in the null. Okay, so this is something to remember as you're working your way through this homework section. Now, once you set up what the null and alternative are, and the null is given to you. They tell you this is the status quo, this is the statement, this is what everyone is currently believing. Okay, but and then you read the narrative and you go, hey, someone challenged that and said, no, I think it's bigger than that. Then that would be it's greater than, or no, I think it's less than that, or no, I think it's different from that. Different would be not equals to. So once that's established, what will happen, not in this section, but in the next couple of sections, is you will run a statistical test to decide whether there's sufficient evidence to reject the status quo, the null hypothesis, or whether there's not sufficient evidence to reject. Okay? So it's weird wording because we would like to say, oh, I'm either going to accept this or I'm going to cancel that and accept this. But we don't use those words. What we say is, I either have sufficient evidence to reject the null, so I have sufficient to reject the null. Okay, so what would have happened is you would have done a statistical analysis to determine whether your alternative seems viable. And if it does, and we'll learn in 10.2 what we need to do with that statistical reading in order to determine that the alternative is viable. But what you would say is you would say, yes, I found sufficient evidence to reject the null hypothesis, which is kind of like saying that you think your alternative is more correct, but we don't use those words. We just say there's sufficient evidence to reject the null. Okay, or we would say there's not sufficient evidence to reject the null, which is essentially saying we're going to keep with the null. Okay, so these are the two ways that your results would be stated. You either determine that there's sufficient evidence to reject the null, which is insinuating that your alternative is more truthful, or you're going to say there's not sufficient evidence to reject it, which is saying basically we're going to stick with it. Okay, so these are the two choices once you read your data, which again doesn't happen until 10.2. Now, what else do we need to talk about? We need to talk about committing an error. So let's say that you interview 200 people and determine that the evidence you collect would suggest that you could reject this null. That in fact your sample showed that it was higher than the 1.2. So the evidence is telling you to reject the null. Okay? But let's say you got it wrong. And who knows why? Maybe you miscalculated something or whatever. But the point is that you've told everyone that you have sufficient evidence to reject the null, but in fact, you should not have rejected. So this is what's called a type 1 error. So a type 1 error, let me see where I put this. So type 1 error is when you reject the null, but you should not have. Now, as you're going through the questions in 10.1, read it carefully, because they have a lot of funny ways of saying this statement, okay? Oh, I committed a type 1 error. It's because I rejected the null, but in fact, there really were an average of 1.2 energy drinks consumed per person. In other words, I rejected it, but I should not have, because this was actually truthful, okay? So that would be a type 1 error. A type 2 error is the other way around. It's when there really was sufficient evidence to determine that we should reject the null. So basically our hypothesis is looking pretty good, but we don't reject it for some reason. Like we second guess ourselves, or we've read something incorrectly. So there's two ways to mess up. In other words, you can reject the null, which is essentially saying that you like this one better, right? But you shouldn't have, because this really was the more correct hypothesis, okay? Or type 2, you should reject the null. You should reject it, but you didn't. Okay, are these important? Yes, these are important, and you have to remember which one is which. You have to be able to express what a type 1 error is, not only generally, but in any given situation for the homework problems. You also have to recognize, what a type 1 error would look like, and then the same for a type 2 error. A little story I like to give that helps people remember, I think, is to think of it like a personality. A type 1 personality, most people think, oh, this is a person with a lot of confidence and maybe a little bit cocky. What are they going to tend to do? They want themselves to be right. So they're going to be likely to make a mistake and be like, no, I reject that. My alternative hypothesis was more correct. I'm going to reject the null and go with my alternative. But in fact, they made an error. They jumped the gun because they really, really wanted to be right and prove something, okay? Think of a type 2 error as like a type 2 personality. This is someone who's pretty timid. They don't have a lot of self-confidence. They often think they're wrong. So what happens is that they run an analysis and it turns out they should reject the null and go with theirs, but they lack the confidence in believing in themselves. So they don't. They don't go with theirs. They decide to stick with the null when in fact they really did come up with something profound, okay? So sometimes that helps to get this organized in your brain. One recommendation I would make is, before you read the answers in the homework questions, develop your own words for explaining the type 1 or type 2 error. In other words, if I had this question here about energy drinks, and they said to me, well, what would it mean if you committed a type 1 error? I would come up with it in my own head first. A type 1 error would mean that I rejected this null because I really thought my hypothesis was true, but I was wrong. I had jumped the gun. I would get this in my brain before I read the potential answers, because once you start reading them, it can be super confusing. You have to really pay attention to the specific words that they use. Okay, so last thing I want to talk about in this lecture is we can give a probability for committing a type 1 error, and that's really all we care about for the most part. We're not going to worry too much about the type 2 error regarding this. And so let's say that we figured out that I have a 1% chance of committing a type 1 error in a specific study. So I would call that an alpha level of significance. If my alpha is 0.01, we would call that my level of significance. And what it means is that I have a 1% chance of committing this type 1 error. Okay, so I'm going to put this in a little different color so that it'll stand out. So this means I have a 1% chance of committing a type 1 error. Okay. If the level of significance was 0.05, then I would have a 5% chance of committing a type 1 error. If it was 0.10, I would have a 10% chance of committing a type 1 error. So there's a very specific connection between this level of significance and the chance of committing a type 1 error. Okay. All right. So that's all I have for this section. Once we jump into 10.2, we will actually be conducting the statistical analyses, so that not only do you have the null hypothesis and the alternative hypothesis, but you can make a decision about whether you would reject or not reject the null. Okay? That's it. Thank you. Bye.